This is 8.1 lesson 1, and for this lesson we're going to look at parallel lines that are cut by transversals. So for this lesson we have quite a few vocab words. So as we go through this front page we're going to define some of these words and then do some examples with them. So our first word is parallel lines, and they are two lines that never intersect. Okay, so A and B here are a set of parallel lines. Our next word is a transversal, and that is a line that intersects two parallel lines. So in this example, our line that cuts through is our transversal. Our next word is complementary angles, and these are two angles that add up to 90 degrees. So in this example, angle A plus angle B equals 90 degrees. So looking at an example of this, we know that we have an angle here that is 54, and we don't know what this other angle is, so we're going to call that x. And we know that 54 and x together make 90 degrees. So we're going to have x plus 54 equals 90. We're going to solve this equation, so we're going to subtract 54 on both sides to get x equals 36. So our angle is 36 degrees. Supplementary angles are two angles that add up to 180 degrees. So in this picture, angle A plus angle B equals 180 degrees. So looking at our example, we know that our smaller angle here is 44, and we don't know what our larger obtuse angle is, so we're going to call that x. And together we know that they create this straight line, or 180 degrees. So our equation is x plus 44 equals 180. We're going to subtract 44 on both sides to get x equals 136. So our angle is 136 degrees. Okay, next we have vertical angles. And vertical angles are a pair of angles or a pair of, opposite angles made by two intersecting lines and these angles are going to have the same measure. Okay, so for example, angle 1 is opposite angle 4. Okay, so those are vertical angles. So one example is angle 1 and angle 4. Another example is angle 3 and angle 2. And again, like I said before, they're going to have the same measure. So that means the measure of angle 2 is going to be equal to the measure of angle 3. So looking at these vertical angles, I told you that angle 3 is 139 degrees and angle 4 is 41 degrees. Okay, so angle 3 is a vertical angle with angle 1, meaning that those two are going to have the same measure, 139. Whereas angle 4 and angle 2 are opposite or vertical angles, so they are going to have the same measure of 41 degrees. Okay, our last definition is corresponding angles. And corresponding angles are two angles in the same position when a transversal crosses two parallel lines. And these angles also have the same measure. So for example, looking at this picture, angle 1 and angle 5 are in the same spots of my four corners here, meaning that they are going to be corresponding angles. And since they're corresponding angles, that also means they're going to have the same measure. So another example of this would be angle 2 and angle 6. Again, they're in the same position. They're going to have the same measure. So looking at an example of this, I told you that angle 3 is 125 degrees. And then angle 4 is 55 degrees. Okay. Angle 3 and angle 2 are in the same position of my four angles here, meaning that they are going to be the same measure. So angle 2 is going to be 125 degrees. Whereas angle 4 and angle 1 are in the same position, so they are corresponding, making them have the same measure of 55 degrees. So now I tell you that angle 1 measures 123 degrees, and we have to find all of our other angle measurements. Okay, so the first thing I want you to notice is angle 1 and angle 2 create a straight line, meaning that they together make 180 degrees. So in order to find angle 2, I can do x plus 123 has to equal 180 degrees. When I subtract 123 from 180, I get 57 degrees. Okay, so angle 2, we'll write that over here, is 57 degrees. Now to figure out the rest of the angles, you have several different things you can think about. One is that angles 1 and angle 4 are vertical angles. And we learned that vertical angles, they're opposite of each other when two lines cross, and their measures are equal. So that means the measure of angle 4 is 123 degrees. Angles 2 and 3 are also opposite when two lines cross. So they are also vertical angles, meaning that angle 3 is 57 degrees. Now the next thing we need to look at is angle 5. Well, if you remember from the previous example, angle 5 and angle 1 are corresponding. They're in the same location, which means that they have the same measurement. So angle 5 is 123 degrees. Angle 2 and angle 6 are in the same location, meaning they have the same measurement of 57 degrees. Angle 3 and angle 7 are in the same spot, so they both have a measure of 57 degrees. And then angle 8 and angle 4 are in the same location, so they both have 123 degrees. If you notice, when we have two parallel lines cut by a transversal, as long as they are parallel, we only have two sets of angle measurements for all of our angles. Number 2 says name the pairs of vertical angles. So we actually talked about this as we went. Angle 1 and angle 4 we said are vertical. They're across from each other when two lines intersect. Angle 5 and then angle 8 are going to be vertical. They are opposite each other where two lines intersect. Angle 3 and angle 2 we already said were vertical angles because they're opposite where two lines intersect. And then angle 7 and angle 6 are also opposite of each other. And our last one says name the corresponding angles, which we also talked about as we went. Angle 1 and angle 5 are in the same location, so they are going to be corresponding. Angles 2 and 6 are in the same location, so they are corresponding. Angles 3 and 7 are in the same location, so they are corresponding. And angles 4 and 8 are in the same location, so they are corresponding as well.